Good morning, everyone. Thank you for tuning in today because this is a very important video as we prepare for our final test on June 12th, next Friday, next Friday. We're going to tie together everything we did with the last unit with what we've been doing these last few weeks with solving equations. This all connects, even if it hasn't been clear yet. Hopefully by the end of this video, in today's assignment, things are more clear. So we're going to bring y back into the mix. So I want you to think back, remember how we worked with y, for several weeks. And we're going to see how solving equations, solving for x, these one-step, two-step equations, helps us with these graphs and tables and how it just connects to everything. So just a little review here. Remember when we decided to graph, we said, okay, we could take some different numbers for x. Right? It doesn't really matter what we plug in. And if you go ahead and plug that number in for x, well, you use your equation to tell you what you should get for y. So for example, we plugged in for this first row here, we said, okay, if x is -1, well, then we do 2 times -1, and that would give us -2. Why? So this here was one solution, right? And we said that was actually a point on our graph. It's actually not on this one, so I'll show you for the next point. So again, for the next row, for this one here, okay, when y is 0, well, then we know when x is 0, then y is 0. Because if you did 2 times 0, that would give you 0. So we know 0, 0 is a solution. So that's a point on our graph here. We'll come back to this, right, because we're missing the x here. What about this one here? So 5, 10. Well, when x is 5, we do 2 times 5, and that gives us y equals 10. And if you actually went ahead and graphed it, let's see, 5 would be about right here. So 5, 10 would kind of be way up here, maybe about right here, if you kept this graph going. So it's but let's talk about this, because this is something I started off this last unit with, a type of question like this. I said, okay, what if we know y and we don't know x? In the last unit, we had tables like this where I might give you the x's, like 1, 2, 3, and then let's say we have 4, 5 for y's. We had 4, 5, and then I'd say find this. What's y there? Well, for what we're doing now, what we're able to do is find x, or when the question mark's on the other side. So that's our goal here. We want to find x when y is equal to 4. Yep, just like what I have there. So to find x, what we can do is plug in 4 into our equation, and again we'll use the equation to solve it. But this time it's going to look a little different than how we did it for the last unit. So let's start off. We had our equation, y equals 2x. And we want to find out what x is when y is 4. I have the answer down here, but it doesn't matter for this part. Right? We see a 4 here, and this is what we're trying to find. Right? This was our question mark. So we're going to plug in a 4 for y to get started. And then from here, this is just a one-step equation. All right? We already practiced how to solve these. So since we're multiplying times x over here, times 2, we take the opposite of multiplication division, and we divide both sides by 2. 2 divided by 2 is 1, so these go away, leaves us with just x. And then on the left side, we have 4 divided by 2, which is just 2. So that means that when y is 4, x is equal to 2. Right? And that's why I filled it in there. So our solution would be the point 2, 4. And I'll show you that. So if you look at the graph, if it's a solution, this point here should be on it. Well, when x is 2, you see that y is 4. So this must be the point 2, 4. And so we did it right. It's on the graph, so we must have did it correctly. So now we're going to do a similar but a little bit harder problem. We're going to add a Y-intercept into the mix, right? So remember we said this was our Y-intercept. Notice it's going through the Y-axis right here. So again, I gave you a table, and I said, okay, let's find what this number is. We want to find x when y is 22. So what we're going to do is plug in 22 in for y, and then solve for x. So this is going to be the two-step equation we're trying to solve here. All right, this just should look like what we've done all week. So let's take a look. Remember, we do PEMDAS backwards to decide the order we should go. We know we start off with addition and subtraction, and we're adding 1 here. So we're going to get rid of this 1 first. To get rid of this 1, you take the opposite of adding, which is subtracting. So our first step is subtracting 1 from both sides. So we do 22 minus 1 on the left, and then on the right we minus 1. But these cancel out, right? Because 1 minus 1 is just 0. So these go away. And that just leaves us with this on the right, 3x. And then on the left, well, 22 minus 1 is 21. So now we have 21 is equal to 3x. So we want to solve for x here. So again, we're multiplying 3 times x. So to get rid of this 3, we need to divide. Like you see here. We're going to divide both sides by that 3. So this 3 goes away. And then we only have an x on the right. But we have to do the same thing to the other side so it stays balanced, like we did on the scale. So 21 divided by 3 gives us 7. So this is telling us that when x is 7, y is 22. If you were to graph that, we'd run out of room here, but it'd be way up there. Yeah, okay, so you can actually see it on the graph here. I did zoom out so that we had a little bit more room to graph with. And you'll see, if you actually connect it further, that it's right here on the graph. So this is a solution. When y is 22, x is equal to 7. And actually there's infinite solutions for this, right? Because any point on this graph, if you plug in that x and y, it's gonna work for that equation. So these are all solutions. There's infinite of them. This line goes on forever. So let's look at some examples. I have a Google form assignment that I put together for you guys. So I'm going to go over some similar questions I put together from the assignment and just kind of build on, get some practice on what I was talking about. So we need to solve for x when y is equal to 11. So what we're going to do is you get an equation like this. We're going to plug in 11 for y. Okay, so that's what you'll see here. We're plugging in this 11 for y, and that gives us this down here. So now we have 11 is equal to 3x plus 2. So now this is a two-step equation. We have to decide how we want to start. We're adding 2. So to get rid of the 2, we need to subtract 2. But we have to do the same thing to both sides, right? So we subtract 2 on the left as well. So you see in blue. And then we know 2 minus 2 is 0. So these go away. So it just leaves us with 3x on the right. And on the left side, well, we did 11 minus 2. That gives us 9. So 9 is equal to 3 times x. So again, we're multiplying 3 times x. So to get rid of that 3, we need to take the opposite of multiplication, division. So we divide both sides by 3. On the right side, that leaves us with just x. On the left side, we have 9 divided by 3, which is just 3. So when y is 11, x is equal to 3. If we were to graph this point, it'd be the point 3, 11. So just like the band. But you guys are probably too young to know that. So, all right. Solve for x when y is equal to 12. So again, it's the same type of problem. This case, y is equal to 12 now. So we know y is equal to 12. So we're going to plug in 12 for y here. That's how we're going to get started. And now we have a two-step equation. We're subtracting, which we know comes first in PEMDAS reversed. Right? We see addition, subtraction first. And then from here, well, we're subtracting 4. So to get rid of this this negative 4, we have to add 4 to both sides. So we add 4 so that this minus 4 goes away. And it leaves us with just 2x on the right. And then on the left, we have 12 plus 4, 16. So now we have 2x is equal to 16. And now it's just a one-step equation. We're multiplying 2 times x. So to get rid of that 2, we divide both sides by 2. Leaves you with just an x on the right. On the left side, you have 16 divided by 2, which is just 8. So when y is equal to 12, x is equal to 8. If we were to graph this point, it'd be the point 8, 12. That's our solution. Alright, so this is the last example I'm going to cover for today. So you're going to see questions like this as well, kind of like what I was going through at the start. So I gave you some examples, solutions here that work for this equation. You actually don't really need to use those for anything. They're just kind of a reference, something for us to keep in mind. Don't try and look for any patterns with it, because notice x is, it's not counting up by ones, right? We're kind of jumping all over the place. So we're going to just follow our steps here. So we know that when we want to find out what x is when y is equal to 107. And we know that this table is represented or matches this equation here. This is what we're going to use to actually solve for x. So when y is equal to 107, well, we just plug in this 107 for y. So this is the two-step equation we have. 107 is equal to 5x plus 7. We subtract first. So we're going to subtract 7 from both sides. On the right side, these cancel out because 7 minus 7 is 0. On the left side, we have 107 minus 7, which gives us 100. So now we have 5x is equal to 100. Now this is just a one-step equation. So we need to get rid of this 5. To get rid of that, we have to divide both sides by 5. If we divide both sides by 5, these go away and leave us with just x. And then on the left, 100 divided by 5 is just 20. So we know that when x is 20, y is 107. And this means that this point, 20, 107, would be a solution and is on the graph. So that's kind of the trick today. We're plugging in for y and then solving a two-step equation. That's all these problems are. They're all the same type of thing, same method, but I do really want you to kind of take away from this why we're doing it and how it connects to the graph and tables that we've been using. So yeah, I'm not adding much more into the mix. It's just something for you to think about and kind of something that we can do now that we've been working on one-step and two-step equations for the last few weeks. So that's all I have for you guys today. Hopefully you found this video helpful. I will be posting this PowerPoint as well for you to reference. And we'll also talk more about today this week's work during our live stream tomorrow, Friday at 10 o'clock a.m. like usual. So thank you guys. Please take care and good luck.